All right, so we had said that the ultimate source of energy in the biosphere is the sun. And so we can go on and elaborate a little bit more about that, and we can say that the kinds of life that is able to extract that energy and use that energy for life, these would be what we call primary producers. And they are the first line in life. You have to have something that is capable of using energy to build biological macromolecules, and the main way this happens on Earth is through a process called photosynthesis. And these would be what we call primary producers. Now, you and I like to go to the Caribbean. Last March, during spring break, we were in the Dominican Republic. We're not going to be there this time. Travel isn't allowed, but during most spring breaks, we like to go to the sun. But I still have to eat. It doesn't matter how much I hang out in the sun, I can't make energy. I have to eat. So I'm not a primary producer, I am a consumer. So you and I are consumers. So what are primary producers? They're plants and algae, things that can, primary producers are organisms that can convert sunlight into complex biological macromolecules. And the process of doing this, the process of taking sunlight energy plus CO2 from the atmosphere plus water is called photosynthesis. And what do you make? The products of photosynthesis are biological macromolecules. So CO2 plus water plus energy makes biological macromolecules in a process called photosynthesis. Now, it ends up, I said, the main way that we do this is through photosynthesis. But there are a few other kinds of primary producers. And one of them, so if you think about the ocean, light will penetrate into the ocean, depending on how clear it is, a couple hundred feet. But it's only like 30 feet or something like that is what we call the photic zone, where you have where the light has enough energy to be used for photosynthesis. But the ocean is really deep. I might have mentioned, I know I did, I mentioned that I was doing work when I was out on the ship in the Bering Sea. We did some sample collections where we found life in 12,000 feet of water. Well, that's not how deep the ocean gets even much deeper than that, over 30,000 feet. Well, it ends up, if you go to places like the Marianas Trench, these really, really deep places, you find some communities of life. And they're connected weirdly to what we call hydrothermal vents. And what this is water coming up out of the bottom of the ocean floor at like 400 degrees Fahrenheit. And it's so hot that when they send a submersible down there with a camera, you can see the water shimmering. And there's a teeming with life. And so it ends up, there's this chemical-based life food chain that exists in these hydrothermal vent areas. And I have a video that there's a link to here on this page, which says some producers use chemosynthesis. And this is where they're taking high energy inorganic molecules and using them as the basis of life. So it's a different form of life. But now, I mean, we don't live on the bottom of the ocean, and most life is not found on the bottom of the ocean. But we are saying this is an alternate way of producing energy. So how do we do it? We do it, and most producers, most of the life on Earth is produced using sunlight energy. Now it ends up, there's all kinds of energy from that sun up there. And there's just this one small portion of it that is what we call the visible light spectrum. The energy coming from the sun, it has X-rays and gamma rays and all these, ultraviolet radiation, all this stuff that is bad for us, right? That's so high energy that it would just blast our molecules apart. So the problem you have is the sunlight energy, some of it is so powerful, it just blows molecules apart. And then some of it is too weak. So we have this part right there in the middle that we call, or in one section of it, not necessarily the middle, but there's this one section of it where it's high enough energy to be used to build biological macromolecules, but not so much that it will blow them apart. And this is the visible light spectrum. And we're in the planet that has the right amount of visible sunlight. If we were closer, we'd just be boiling hot and the molecules of life would be blasted into, individual atoms. And then if you were further away, like Mars and beyond, you don't really get enough sunlight. And so when we talk about we have to take care of the Earth, well, the reality is that we're really the only planet that's the right distance from the sun to really support life. And it's because we get a lot of that light that's just at the right level of energy, and it's what we call the visible light spectrum. And that is what these primary producers are using to make the molecules of life, the biological macromolecules. Okay, so when we look at photosynthesis, it ends up there's two different processes, and I'm not going to have you. We're not right now going to be learning anything about photosynthesis, and with this course we don't really get into the details, but there are two sets of reactions. There's the light-dependent reactions and the light-independent reactions, the Calvin cycle. So you extract this energy with one set of reactions and then use it to build the biological macromolecules. In this process we call photosynthesis. So we've made the biological macromolecules, right? So through photosynthesis, we make these biological macromolecules. And then the thing is, but we said, I can't do that. You can't do that. That rabbit out there can't do that. No, we have to have, and believe it or not, the plant also has to be able to break that molecule down to produce energy. So the plant can use photosynthesis to make biological macromolecules, but the plant and you and me and that rabbit out there, we all have to be able to use the energy that has been stored in those electrons. Now, you know what happens? I didn't talk about this. During photosynthesis, we had said those electrons, sorry, we go back to that physics. Those electrons, we had said they can be low energy or they can be higher energy. And we had said, you know what happens in photosynthesis? Sunlight comes down and it raises the energy in an electron. And so that electron goes from a low energy shell to a higher energy state. Okay, so these electrons are used to build biological macromolecules. Well, guess what? When you and I eat a candy bar, eat food, whatever it is we eat, we tear that molecule apart and we use that excess energy that came from the sun to do that work. And that electron that had extra energy becomes a low energy electron again. And it's part of that water. So we have this second process that's all about tearing that thing down. So we start out, and it's called cellular respiration. And so we start out with energy from the primary producers, and we either have eaten some lettuce or a carrot or something that is eaten, they eat lettuce or carrot, but we'll say we've been eating vegetables, and we take the sugars in that carrot and we break them down into carbon dioxide and water. So we have a carbohydrate, and we break it down into carbon dioxide and water plus energy. That is what happens in this companion process. It's a companion to photosynthesis. So photosynthesis is building, and cellular respiration is tearing it down. And all of this is all part of that cycle that I keep mentioning cycles, and in particular I talk about the carbon cycle a lot because it's central to life. Okay. Guess what? That's all I'm going to talk about today. So I'm going to stop right here, and we'll come back and we'll start talking about ecology on Tuesday. And guess what? I'm going to see your shining faces in lab, 9:35 in the morning in Cranberry. Don't miss it. You're going to be there. I'm going to be there. See you then.